We're going to talk about that briefly, but to kick that off, we're going to talk about the CJP SOPs. So you all now have had the time to become familiar with the CJP SOPs, so we're going to warm up with a nice, easy category. So, start with the daily doubles. This is going to be 200 points, Cheryl. So, Team Mustang will answer first. If an electronic or visual descent path aid is available, the computing landing distance should be equal to or less than what? This is all coming out of our CJP SOPs. So you guys have 5 seconds to get the answer together. All right, Mark, what's Team Mustang's answer? What's Team G3000? 60% of the runway. All right, Team Mustang, electronic visual descent path is available. What is the answer? 60%. You can all answer the same answer. Over here, guys. Over here. All right, Charlie and I are going to spend the next hour and a half reading the SOPs to you guys. You just earned yourselves attention because you're all wrong. The answer is 80% of the available landing distance. All the teams are at negative 200 points now.
Did you lock on to the fact that it said a visual descent path aid is available?
Is available. Not available. All right, so here's your chance to bring yourself back to zero. Another one. We're going to get them all out of the way. When, according to the CJP SOP, should the pilot obtain runway condition reports? And the answer is not always. When should the pilot obtain runway condition reports? You have 5 seconds to talk it over. If anybody wants to run to the front, talk to their captain before it. All right, we'll go backwards this time. We'll start over here. Team Pro Line, what do the SOPs say? Team Pro Line, Randy, go do something. Okay, on the ground before departure and before arrival. Team Mustang. During pre-flight and before landing, okay? Team G3000. Oh, and Team G3000 for the win. So what the SOPs say is that the runway is predicted or anticipated to be ice or snow covered. That's what our SOPs say. Not that the other answers weren't smart answers, they just weren't the right answer. All right, so that means Team G3000 is up 400, the other two are down 400. Cheryl, you keep got this? Okay. All right, 300 points, CJP SOP. Okay, we are getting a lot of wow. Look at that. If conducting a visual approach at night to an unfamiliar airport, the runway should have what? 5 seconds. 5 seconds. Please give your captain the answer. Visual approach at night, unfamiliar airport. The runway should have. All right, John, you're going to start.
Oh, yeah, okay.
Let's say approach with vertical guidance. Precision approach with vertical guidance. All right, over here. Happy or Bazzi. Okay. And over here. An approach with visual guidance. An approach with vertical guidance. All right. So the answer, according to the CJP SOPs, is that there should be an instrument approach with vertical guidance. So we're going to do that. We're going to get that to 1,000. Unfortunately, so the SOPs, we talked about this actually. We decided to, maybe be a little more conservative, just a tad or we actually wanted it to have an approach with vertical guidance. If you're going to an unfamiliar airport, that's the key point. An unfamiliar airport you haven't been to yet. So that's another 600 points added for G3000, G1000, 600 off of Pro Line. Thank you guys for sharing the ground with these guys this year. We all appreciate it. All right, last question on this category. Then we're going to go to a couple points from Charlie. 500 points CJP SOPs. If conducting an approach with the autopilot engaged below what altitude should the pilot have a hand on the yoke at all times? And we'll give 5 seconds. I'll go back to G3000 to start. You do all realize that the SOPs are available online. Team G3000. What? 1,000 1,000 feet, Team Mustang. 1,500 feet, Pro Line. 1,000. And the answer is 1,000. The answer is 1,000 feet. So Team G 3,000 and Team Pro Line is 500. Team Mustang loses 500.
By the way, that particular SOP is in a way it's linked to the runway trim failure or other trim issues or autopilot issues that we talked about at the beginning. Catching on the yoke, we're ready to take action, take manual control.
And Jim, can we switch back over to Charlie's laptop now? Oh, and here's the score if you're curious right now. Wow, I call that a blowout. We do have 3 more attempts though, 3 more categories where we keep it running total. So, I mean, that was the again.
All right, so when we finish the session today, we're going to have a couple of handouts where I mentioned. This is a concept that is going to be complementary to the SOP handbook that we gave you last year. This one's called the in-flight guide. It's a thing that we used in the military and NASA. It's a compendium of a number of reference items that you can have handy when you need it. And so if you look at the table of contents here, there's some briefing guides in there, there's some approach info, all kinds of stuff. We will go over these as we get into the videos on Saturday in more detail. But take one and take a look at it over the next day or so you get familiar with what's in it. If any of you are familiar with, go to the next slide. Or maybe I need to do it. I think we'll go to work on it. Can you advance that for me? There you go. How many of you are familiar with this little pamphlet that the OT hands out with the flight planning guys? If you don't have one, it can be, you can download and print from our website. You can go to the CJP website, and you can go to the Russ Meyer Library, and just type in the search flight planning guides, and it'll have them all in there for all the models. But the stuff that's in here is nice, handy to use stuff. I keep one in my side pouch. So things like fuel flows during holding, things you don't hardly ever need, but it's there and it's a nice reference. So the same concept is true. That wasn't supposed to go on. The same size pamphlet is now in an in-flight guide, and you see the table of contents there. Like I said, there's a lot of cool information there that you may need occasionally, but not every day, and then you can get access to it if you need it. So things like the matrix for the runway condition ratings is mapped to our landing data table, so all that stuff will be in there. We'll go through that in more detail. Okay, let's go.
Okay, back to the game. So we're going to move on. We're going to talk about circling approaches for about 10-15 minutes. Hopefully you're going to stick around Saturday morning. David has a great video we're going to show on Saturday morning of circling approach gone wrong. But in the meantime, we're going to warm up by asking some questions about circling approaches. So let's start with the winners right now, the leading team, G3000. Will give us the first answer, but again, you'll all get to answer. Citation with the VREF of 108 knots at max landing weight is circling at a weight that gives them a VREF. Wait, that's impossible. All right, well, just ignore that. If a citation is circling, oh no, that's right. I thought it was the numbers backwards. VREF of 101 will fall into what category? So the citation's normal, max gross weight, max landing weight, VREF 108, the actual weight, their VREF is 101. What category are they going to be for circling? 5 seconds is up. G3000. What category?
We're going to go with Charlie.
Charlie. Team Mustang, G1000. You're going to go for Charlie, and you're going to go for Bravo. I'll give you guys a tip. I'm a designated examiner, and when people give me an answer in an oral exam, and I think they're generally doing well, but they give me the wrong answer, I'll say, wait, one more time, what was that? So good job, you guys switched to the right answer. So the answer is Charlie, category Charlie. So we have 100 points for G3000, 100 points for Mustang, Team 1000, and 100 points off for Pro Line. Next question. And we are going to, by the way, for these next 3 categories, we are going to go over the answer in the presentation. All right, under the old Terps, what is the protected radius around the airport for a Category C aircraft under the old terms? Category C aircraft. Let's start with Proline in 3. All right, Randy, what is it? 2 miles. Team G1000, what is the answer? Old Terps, 1.6. Team G3000, 2.1. Okay, Cheryl, you can subtract 200 points from every team. The answer is 1.7 nautical miles under the old Terps. 1.7. Again, we're going to talk about these in a bit. All right, 300 points. When circling in the protected area, inside, let's say about 1.7, at MDA, how close vertically could an obstacle be to the aircraft? You're flying right at MDA, your altimeter works perfectly, you're flying right at the right altitude. How close per terps are you allowed to be to the top of a cell tower or building? So talk it over for a few seconds. We'll start with G1000. Team G1000, need an answer. 500 feet vertically. Team Proline, need an answer. 500 feet. Okay, we have 2 teams saying 500 feet. 3 teams saying 500 feet. All 3 teams lose 300 points because the correct answer is 300 feet. So think about that when you're circling. You could be 300 feet above the top of an obstacle as you're maneuvering at MDA. All right, last question is circling, and we'll talk about circling a little bit. If you see a C in a box or a diamond in the minimums box, what is the range of protected areas a Category C aircraft could have? We said before under the old terms it would be 1.7. But if you see the C in the box or the diamond, it's actually a range of distances. And this is worth 500 points because this is a pretty hard question. So talk it over. I think we're back to these guys to start.
Yeah.
All right, Mark. That's a number, not a range. Yeah, so I need 2 to 4, for example. I need a range. It's not a single number, it's a range. Yes. The unit is nautical miles, and I need 2 numbers. I need to frame a range. What's that? Okay, 1.7 to 2.3. 2.2. Randy? Randy? Anything? All right, I'm going to take 2 to 2.7, and all the teams can lose 500 points. So under the old terms, it would have been a flat 1.7. Under the new terms, it's a range that starts at 2.7 and goes up to 3.3. We'll look at what depends, what the variable is that determines where that is. So it's a good thing we're going to spend a minute and talk about circling approaches, because that was abysmal. All right, so let's first review what the CJP SOPs say about circling. Charlie, if you want to take it from here.
All right, so we're flying a circle land for approach without an expanded circling protection area, use Cat K minimums. And circling approach mins, 5 miles at night, 3 miles during the day, 500 above the circling MDA, and we must have vast and path air equivalent to vertical path guidance at night. So that's what we put in there, recommending things to do when you're on a circle that protect you. We all know that circling is a hazardous maneuver. And if you have to do it, you ought to consider it as your standards.
And then we also recommend if you have less than 100 hours in type, or if you haven't flown 50 hours in the last 90 days, you take a long break, just don't do circling. Okay, for those circumstances. The minimum angle. You could potentially, you can actually circle to the same runway you shot the approach to. If the angle is steep enough, the descent angle is steep enough, they won't hold the straight intercepts. So there could be a 0 angle, and it's just because you have to maneuver to get back on the road, in which case you get 360. So let's review some of those questions we talked about. Okay. So under the old terms, Here are the radii around any surface of any runway that are protected. So what that means is when you're maneuvering inside this blue area, at MDA, you are guaranteed at least 300 feet of obstacle clearance to cell tower, building, hill, whatever the case may be. So under the old turfs, Category C, as soon as you were maneuvering over 120 knots indicated, you were Category C. So that question, the VREF was 101. For all of the citations that we're flying in the room, Cessna recommends you're maneuvering at VREF plus 20. So that would put you maneuvering at 121, which pushes you into Category C. Other than the Mustang, most of the time we're going to be maneuvering Category C. The Mustang can be light enough that it can actually be still fitting into the Category B, but most of the time we're maneuvering Category C. Now, I said the old turfs. This was the way the protected airspace was drawn for decades in the FAA designing approaches. There was a problem though. If we shot an approach to an airport where our MDA was very high, so let's take Aspen. Okay, the approach into Aspen has a Category C MDA of 10,000 feet MSL. What happens to our true airspeed at high altitude relative to our indicated airspeed? It goes up, right? So if a citation is flying at 130 knots indicated at 10,000 feet, it's actually flying at a true airspeed of 150 knots. And if that plane is to enter a 25-degree bank, the turn radius in a no-wind situation is 1.5 nautical miles. What's our protected airspace? 1.7 nautical miles under the old term. So the FAA took a long time, but they recognized maybe these protected airspaces are somewhat unrealistic because they don't encompass the ability to really accurately maneuver and set up for a circle. For a long time, the international community has recognized this. If you fly outside the U.S., most countries outside the U.S. design their approaches not using the TURPS criteria, but using what's called PANSOP criteria. And under PANSOPs, a Category B airplane that would normally fly approaches B is allowed to maneuver an extra 15 knots on the circle, so up to 135. And the protected airspace is significantly larger, now what I call almost 2.7 miles. So for a long time, if you flew outside the US or Canada, you were afforded much more latitude in terms of being able to fly at a faster speed and in terms of having a realistic amount of protection around the airport that you were maneuvering. So this was not the case, though, obviously, until about 5 years ago in the US. Well, now recently, if you see this C in a diamond on a jet chart, or you see this C in a square on a NATO chart, that tells you that the MDA is based on an expanded circling area. And so this is one of the questions. You can see that the diamond or the square, what are you going to have for protection? So if we look at, under the old system, a Category C aircraft was given 1.7 miles. You see under the new system, we have 2.7 to 3.3 miles. And what determines whether we have 2.7 or 2.8 or 2.9 is the MDA in MSL, because that's what determines how fast our true airspeed will be based on that indicated airspeed. So what the FAA is recognizing here is, hey, if you fly at sea level, 2.7 miles is enough for you to maneuver and land. But if you're flying at Aspen and your MDA is 10,000 feet, we're going to give you an extra 0.6 of a nautical mile because your turn radius is going to go up at the same indicated speed. Okay. Just on time. So as I said, we're going to talk about a couple more points on circling on Saturday. We're going to show a video, and David's going to do some things wrong, and then we're going to show some better ways. But first, we wanted to talk about some common errors during circling approaches and some tips to think about during circling approaches. Important tip. The circling approach is not the time to hold 180 knots to the marker for ATC. Okay, and there have been historically some accidents when pilots have tried to fly too fast into the maneuver, drives up the turn radius, they overcorrect and end up losing control of the airplane. So this is a time we want to be stabilized. Another really important point on a circling maneuver is use the autopilot. All right, it's a pilot in the cockpit that's going to let you put your focus on energy management. How do we use the autopilot during a circle? Remember that every circling approach is a non-precision approach. If you look at the minimums box for the circling, it's going to always say MDA. It's never going to say DA. It's a non-precision approach. So that means we need the MDA to be captured, and that requires appropriate autopilot use. The approach mode is not appropriate because it will not capture the MDA. We're requiring an extra step of ourselves to catch that MDA. Recommend we use the vertical speed mode to get down in time to level off, stabilize the airplane, and set up to maneuver for the airport. We want to do everything we can to set up for this approach ahead of time. Before we reach the final approach fix, let's think about setting that heading bug to the heading we're going to turn to when we start the maneuver. Let's do as much as we can to get ahead of the plane. So the most common mistakes that I see pilots make during a circling approach have to do with the flight path. And over and over again, pilots start the turn on to final too late and overshoot the final. It's extremely rare I see a pilot start the turn too early. Also, over and over again, I see pilots start the descent too late. How many of you have ever been in a sim doing the Memphis Circle and you turn final and you're coming down and the toss starts going off because you're descending too fast? It happens to me. I'm the only guy who doesn't plan my descents in the sim well, and Dave Miller. So this is a really common error. Pilots hold on a little too late to start that descent. There's a couple things we can think about here. When in doubt, know that pilots tend to bias to start the turn a little bit late. So when in doubt, start the turn early. If you realize you turned a little too early, it's really simple to just roll wings level for a few seconds. Likewise, when in doubt, start down to MDA. Okay, this is assuming, of course, you have visual with all of your obstacles. But when in doubt, think about starting down, and also think about what's going to happen when you extend your landing flaps. It's going to tend to balloon you a little bit, and if you're distracted and you're now looking outside, that will be a frequent cause of pilots ending up high. Also, if you click off the autopilot and extend your flaps, but don't pull your power back, what's the plane going to do the second you are distracted? It's going to go right by your clock with the speed and altitude you were deciding. You haven't adjusted the power yet. So we're going to expand on this a little bit on Saturday. This is just a teaser of what's to come from David's video, but we want to leave you with some things to think about. And again, we're going to expand on this a little bit to come. So we're going to go back to Jeopardy for a second now. And we're going to start our next topic of conversation, which are runway excursions. And we do have a video of David Miller after we did the game here. So first, when the OEM is certifying the airplane, how quickly, after the main wheel touchdown, are full brakes applied? When they certify the landing distances, how quickly after the main wheels touch down are full brakes applied? Charlie, you want to collect the answers for this one?
Yeah. So let's see, Mark, what do you got?
3 seconds delay.
3 seconds from the 3,000 meters. 3 seconds.
Keep her line.
Got 2 for 3. Nose wheel plus 3 seconds.
Okay. So the actual answer is 1 second. So when you look at your AFM and you see what Cessna did for a landing distance, 1 second after the main wheels touched the ground, the test pilot was applying full brakes. So Cheryl, that's 100 points off of each team.
So that's a significant thing that happens in a lot of performance data. The test pilot is keyed and ready to demonstrate the maximum performance capability of the airplane. It's not what we're able to do, so we need to be thinking about the fact that we'll never really be what the test pilot can do. But you need to be thinking about not delaying, going full flaps, and moving around.
That's after the main wheel touches. So in 1 second, they de-rotated, got the nose wheel down, and applied forward. In 1 second.
That is the maximum demonstrated capability of the airplane, which we will not likely achieve when we fly.
All right, which of the following are FAA approved? Dry, wet, or contaminated runway landing distances? 1, 2, or 3, or 0 would be the answer to this question. So which of the following, if any, are FAA approved landing distance numbers?
1,000 guys.
None of them are FAA approved, okay?
Okay.
Berlin. Which one? Dry.
Okay.
T3000.
Dry.
And the answer is dry only. So So 400 points for Team G3000 is pro line. So only the dry numbers. We're going to talk about that a bit. That's becoming an important issue. All right, true or false? A 50-50 chance here. If rain only is being reported and the runway is grooved, use of contaminated runway numbers is not necessary. True or false? The only precipitation being reported is rain and the runway is grooved. True or false? Use of contaminated runway numbers is not necessary.
Pro line guys.
There is no third answer, Andy.
False. Okay, well, false. G3000? True. We got a false, we got a true. False.
And the answer is false. So 300 points for pro line and G1000. And we'll come back and talk to that. All right, and our last question on runway exclusions. By what point should an approach meet all stabilized approach criteria in BMC? By what point should the airplane meet all stabilized approach criteria in BMC?
Okay, Mark, thank you guys first. Just a stabilized approach, not approach. 500, okay. What's that, guys? 500? Ready? 500.
All right, 500 points for everybody. The answer is, in fact, 500. Well done.
This year, the Safety and Education Foundation has been focusing on runway overhauls, and for good reason. But just far too many instances where pilots haven't done their homework related to landing performance and requirements. Let's watch.
Thanks, Charlie. As pilots, we have access to a variety of runway information, but how do we access it and use it to our advantage? Imagine we're arriving into a towered airport after the tower has closed on a cold winter night. Let's look at how this played out for one citation pilot.
Okay, Beverly, Massachusetts. We're shooting the LPD 16. Tower's closed. I wish I'd gotten here a little earlier, but that's my fault. Anyway, the weather, it's an hour old. There's light rain in the area. Looks like that's moved out. Temperature is 0-1, so that's above freezing. That shouldn't be a problem. And runway 16 LPD, the runway's 5,000 feet. That's plenty for a Mustang. I'm in and out of the bases here, so it should be a visual approach, but checklist is complete, and we're ready.
Citation 416 Delta Mike, flying 110 until established to clear the GPS runway 16 approach, frequency changes and brief.
And 416 LIK 110 until established cleared LPD 16 for Beverly.
Grand Delta Mike, service runway 28, I'm very welcome to well, speaking to our just making an okay.
6 LI. And Beverly, traffic citation 416 Delta Mike on a 3-mile final runway 16. That snow. It's supposed to be snow. All right, we get this thing stopped. Nice. maximum braking. Okay. I don't think we're gonna make the end of this runway, but I got no hands here. We're gonna go off again. Hold on, everybody. Dang it. Okay, we're gonna go off again. Hold on. Dang it.
I think we all know what was about to happen. The fact that the runway was contaminated certainly wasn't a secret, but it wasn't known to David. Let's look at how this accident could have been prevented. Here's one. David missed the fact, stated by the air traffic controller, that there was an aircraft in front of him on the approach. It could have been a valuable source of information. Boston Center, citation 416 Delta Mike. If that PC-12 is still in frequency with you, could you ask him for a braking action report or field conditions?
Standdown, can you give me a braking action report, sir? 416 Delta Mike, this is the reported moderate braking action and snow on the runway.
We've learned that the rain has changed over to snow, and that an aircraft with propeller reverse is reporting medium braking action. Certainly different than we will experience with an absence of reverse. Or, if we've already switched over to the Unicom frequency, we can start calling the flights directly. If they haven't shut down their engines, they're most likely still monitoring the CTAF and Unicom. We don't always have the luxury of having an aircraft in front of us, but even when the tower's closed, there might be other personnel in the airport who can provide us valuable information. Center, citation 416 Delta Mike, let's go off frequency for just a couple minutes before we start the approach. We're going to try the FBO and see what information I can get from them. And North Atlantic Air at Beverly Airport, this is citation 416 Delta Mike. We're about 10-15 minutes out from landing with you. We're wondering if you had any reports on the field conditions.
Yeah, the 416 Delta Mike, the rain changed over to snow about 45 minutes ago, and there's about an inch on the ramps in the runway now. The cloud guide is, he's not here.
All right, 6 Delta Mike, thank you. With the information that there's about an inch of snow on the ramp and runways, I can look at detailed performance information rather than just assuming a given runway length is going to be enough for my aircraft. With the information we have available to us, we can look at detailed performance for the conditions we expect, not the conditions we're hoping for. With an inch of snow on runway 16, winds calm, using the CJP SOP safety factor, which requires us to be able to stop at 80% of the available runway, we can see that we have to be landing at a weight below 6,400 pounds, or about 1,000 pounds less than our actual landing weight, to have that safety factor we desire. Based on the information we obtained and accurate performance information, we can determine that there's no chance of safely stopping on this runway. Anytime we're operating into a field where there's a possibility of marginal conditions at the time of landing, our SOPs call for identifying an alternate, even if an alternate is not legally required by the FAA. In this case, Hanscom Field is less than 20 miles away, has a 7,000-foot runway, 24-hour snow plowing and chemical de-icing. So we've chosen that as an alternate, and that will be our safer course of action. We don't even have to wait till we're within VHF range to acquire the information. Most of us fly with some sort of satellite phone or communication system. We can begin the intelligence gathering 30, 40, even 60 minutes away from our destination. Give us a little more time to plan. Runway overruns should be a rare event. Please use all the tools available to effect a safe landing.
Great information, Neil, and a special thank you to Flight Safety Textron Aviation Training. These What Good Looks Like videos were brought to you by the CJP Safety and Education Foundation. If you'd like to learn more, please email us at safety@citationjetpilots.com. Have a great day.
stabilized approach, 1,000 feet, 90 feet, 550 feet. The initiated go around of the approach does not meet all of the criteria that we've listed in part 3 of the SOP. And those are plus or minus supported with deflection laterally and vertically, geared flaps as intended, thrust is set at 19 speed, -5 to +20, no more than 1,000 feet from the descent.
And again, just to reiterate those, we'll think of those approach gates, in IMC 1,000 feet, and in VMC 500 feet. And we really want this to be a binary choice, right? There's no gray. You either meet the criteria or you don't. And so we want, thinking about that, let's say that 500 feet in VMC that we talked about, a lot of our systems will generate a 500-foot wall call. So that should be a good prompt to you to tell yourself one of two things. Either I'm stable, I can continue and meet all that criteria, or I'm unstable, I'm doing the go around. And it's really hard to think on the fly, right? So we want to try to take as much of a decision out of this and make it a pretty simple binary process. Further?
Charlie. Okay, and Peter, by the way, presented a little bit about the accident where the overran and burned up the airplane. What we saw in the flight was that they were extremely fast and really didn't have much chance of getting in. So the stabilized approach criteria that we put in there is meant to give you a good go-no-go decision when you think about that. Landing safety margin. So the computed required build less than or equal to 80% of the available landing distance if you have either electronic or visual path indicators to the landing runway, or 60%, which is where we got confused in the quiz question, with no electronic visual descent path indicators available. So we're giving ourselves more margin if we don't have visual guidance.
And why are we doing this? It's good to periodically review how does the OEM certify those dry runway numbers in your AFM, which are, again, the only certified FAA approved numbers. Well, the test pilot goes out, and as many times as they need to do this, to capture this data, they cross the threshold at exactly 50 feet and exactly VREF. The test pilot crosses the threshold a little bit high or a little bit fast, they just don't accept that data set. They go do it again until they get it. So I always tell people, to achieve the OEM numbers isn't a question of being as good as the test pilot, it's a question of being better than the test pilot, because even the test pilot doesn't have to do it every time. So they cross the threshold, they touch down, as we said, within 1 second of main wheels touching down, full braking is applied, and held until the airplane comes to a stop. And that is that dry, unfactored distance you will find in your aircraft. That's how that's generated. But we don't fly perfectly.
And just as a technique, what I do to keep myself in tune with my eyesight on an approach is if I'm doing a visual and I don't have the minimum set for the IFR minimum, I'll set 50 feet radar altimeter as my minimum to get the audio that I hit minimums. And when I'm looking to be crossing the threshold visually, as I hear minimums, and I'm just training myself over and over to get that eye picture for the 50-foot height. And that has a big impact on landing distance.
So let's look at a couple of variables that could deviate from that test pilot optimal. We're just a few knots faster than VREF. Question?
You said that it's electronic right? So, for example, if you have an XI and you develop a visual approach that's giving you vertical guidance, that means that works.
Absolutely. Absolutely. So if the AFM landing distance is represented by that first bracket, a rough rule of thumb is every knot over VREF, we can expect to add about 120 feet for a landing distance. So if we're 5 knots fast, that landing is going to take 600 feet below the AFM distance says. Well, what if we're also a little high? For example, 20 feet over the threshold crossing height. Well, the way the geometry of this works out, every 10 feet high on a 20-to-1 descent path means we're 200 feet farther down the runway where we touch down. So crossing 20 feet above the nominal 50 means we're going to use an extra 400 feet just from this variable alone. And what if we don't have 1 second from main wheel touchdown to full brake application? Well, any extra time we spend in the flare or in delayed braking, at 100 knots ground speed, we're traveling about 170 feet per second. So if we travel 170 feet per second for 3 seconds, that's about 500 feet. Another 500 feet. So you add those all together, and I always make the point, this is not a really sloppy pilot. This is just a human pilot. 5 knots over ref, 20 feet higher than 50, and takes 3 seconds extra beyond the nominal 1. So 4 seconds from main wheel touchdown
That pilot, who maybe only needed 3,000 feet of runway, now is going to actually, according to the AFM, is going to actually use closer to 5,000 feet of runway. The variables add up that way. So as a result, for higher operations, they plan their dispatch requirements are required to be able to stop the airplane in 60% of the distance. And that's where those numbers that we use come from. So far what we've talked about is dry runways, and we want to spend a little more time talking about wet runways, which is why we chose that scenario for the video that we just saw with David. And our SOPs, Charlie, with wet and contaminated runways?
Yeah, so this is another one of the question, right, where ice or snow covered runways are reported or anticipated to get your runway condition or braking action reports if possible.
And another quiz question was the non-dry landing info that we look in our manuals. This is a computation based on dry information. It's not real-world measured data. They don't go out and find a snow-covered runway and test how long it takes to stop the airplane. And Cessna tells you that. If you dig into your AFM for the wet runways, the preamble says this advisory information is not FAA approved. These distances are approximate and are to be considered minimums. All right? And if we look, for example, I think I took this out of CJP, but it's applicable for all of the aircraft. We have this table that converts dry distance into wet distance. And if we look down that column, what we find is that the wet distance numbers are about 40 or 50% more than the dry distance numbers. Okay? Well, the problem is, according to the FAA, there are a lot of situations where the aircraft would require quite a bit more than 40 or 50% additional runway on a wet runway. Okay? If we have a well-maintained, grooved wet runway, we might only need as little as an additional 15%. But what if the grooves aren't well-maintained and they started to degrade? Or what if there's a lot of rubber deposits that haven't been cleaned recently? Well, the FAA says in that case, we're going to need almost double our dry stopping distance, or about 60% over that AFM landing distance. Already we've exceeded what we've been provided in our AFM. It could get worse. How about an ungrooved runway? Or how about an ungrooved runway that's very new or that has rubber deposits? So there are situations where we could potentially, just on a wet runway, we're spending all of our time here really just going to focus on wet runways. We could really need grossly more than what that AFM says we need for a wet runway. And in fact, this has become such a big issue that just about 2 months ago, the FAA came out with this SAFO entitled Turbojet Braking Performance on Wet Runways. So if you Googled SAFO Turbojet Braking Performance on Wet Runways, you can download this publication. I highly recommend you do it, and it's fairly terrifying reading. We're going to show you some of the excerpts, but because we have so many topics we talk about, we're just going to go over it very quickly, but we're going to show you some of the excerpts. So again, it's SAFO 19003. If you wanted to Google it and download it, I cannot recommend strongly enough that you do that. And what this SAFO says is that several recent runway overruns have raised concern and have shown that the braking coefficient of friction that was experienced by the airplane was much lower than what the FAA has been saying you should expect on a wet runway. These incidents have occurred on both grooved and ungrooved runways. So remember one of the quiz questions says, hey, we're landing on a grooved runway and rain is reported, and that's the large focus of this SAFO. And what they found is that if the runway transitions from wet to contaminated, that quite a bit more stopping distance may be required, up to 30 or 40% more than the FAA had previously thought. And they also emphasize that it is up to the pilot to determine if the runway is wet or contaminated. Airports are not required to report that a runway is wet. Rainfall intensity may be the only indication available to the pilot as to what the water depth on the runway is. We're not going to read all of this. I'll give you a second to read that to yourself real quickly. But the point that they're making here is the threshold between a wet runway and a contaminated runway, it can be as little as an eighth of an inch of water. An eighth of an inch of water, which is not very much. And that threshold can be crossed very quickly in moderate or greater rain. Okay, as little as moderate rain on a runway that is not grooved can
make the runway transition from wet to contaminated for stopping purposes. And the takeaways from this are that if you were landing on an ungrooved runway and moderate or heavy rain is reported, or if you were landing on a grooved runway and heavy rain is reported, you should assume that the runway is now contaminated and use your contaminated runway performance numbers. And they also want to emphasize to you that you may not know just from listening to the ATIS if this is the case, because a special ATIS is not required to be generated if the rainfall rate changes. This is not a condition that triggers a new ATIS. So they could be reporting light rain on the ATIS. It could have switched to moderate or greater rainfall. So pilot beware is the takeaway from this. One last point that we wanted to talk about, showed a little bit on that video, is the use of runway analysis services for landing performance. We've talked a lot before about runway analysis, looking at takeoff phase of flight. But in that video, where David was just going off of instinct and saying, hey, 5,000 feet, we're reporting rain, that's enough. Then we're showing, okay, if we actually dig in, we call the FBO and they say, no, there's about an inch of snow on the ground and the flower's gone home for the night. Well, we can look up what is an inch of snow. That's information that's provided to us. If we look into the runway analysis, as I did in that video, we can see at my expected landing weight, will I be able to stop in that 80% margin that we recommend in the CJP SOPs? And there's another use for runway analysis, which is that for landing, which is that it lets you very easily and quickly do an A/B analysis. And we're going to talk about what I mean by that in 2 slides. But first, we're going to look at an accident that happened in this context. This was actually a Phenom 100. But you'll see in a second why we're talking about this at a citation conference. This Phenom 100 ran off the end of the runway and rolled down into a ravine. Thankfully, everybody on board survived with minor or no injuries. And I want you guys to just answer real quickly. Take a look at this. This is the airport diagram, and that's the METAR. So we've got a choice of runway 21 or runway 3, and the winds are 250 at 5 gust 14. What runway are you guys going to land on? I wouldn't be asking if it wasn't a trick question. All right, so I heard a lot of 2-1s. What if I told you that the threshold of 2-1 was at 4,827 feet and the threshold of 3 was at 4,736 feet? And when you do the math, that is almost the limit of what we are certified to land a turbojet on. Does anyone want to change their vote? So our choices, we can land on 2-1 with a 10-knot headwind, or we can land on 3 with a 10-knot, we can land on 2-1 with a 10-knot headwind, but downhill, or we can land on 3 uphill with a 10-knot tailwind. How many of you, show of hands, would land on 2-1? How many of you, show of hands, would land on 3? And how many of you would tell your co-pilot your airplane? Alright, so this particular aircraft landed on 2-1, and it turns out, if we look at the runway analysis, I just picked a CJ3. We look at the runway analysis for CJ3, and just to give you a quick briefing on how you would use this product if you're not familiar with runway analysis. This would be a report that can very quickly generate, and I would say I'm going to be landing at this airport. The runway is going to be dry, and it will show me, okay, you can land on runway 3 and you have a 1.8% upslope, or you can land on 2-1 and you have a 1.8% downslope. These safety factors that we are using, that we are recommending, the 60%, 80%, these are industry standards. We didn't make these up. So these are integrated into this runway analysis program. So I can go look and I can say, okay, I've got visual approach guidance or electronic approach guidance. So for my CJP SOPs, I'm going to use the 80% column. So I'm going to ignore the other columns. And then I'm going to say, well, if I land on 3, I'm going to land with a 10-knot tailwind. If I land on 2-1, I'm going to land with a 10-knot headwind. And what I can look at there is I can say, okay, I can land up to 12,750 pounds, which is max landing weight in CJ3. I can land up to that distance and stop in 80% of the available runway if I land with a 10-knot tailwind, but land uphill. If I choose to land downhill, then I have to be at least 400 or 500 pounds less. Now, I could also do something similar with the runway analysis if I know my exact landing weight. I could do a similar input. In this case, I'm just generating a chart, for example, I might use before I use this to be part of my pre-flight plan. But I can instantly see I have a much greater margin of safety to just accept the tailwind and land uphill. Why am I bringing this up? There was a lot of conversation recently on the forums. We don't know what the final outcome is going to be, but one of the rash of accidents that just happened was about a 1% slope. Do you land downhill with the headwind? Do you land uphill with the tailwind? There's no intuitive way to know for your airplane and for your weight and this slope and this wind, where's the crossover point? There's no intuitive way to do that. Again, use the data, right? That's what we're trying to emphasize here, is use the data. It's there. Cessna spent a lot of money getting this information. Use it. All right, so we're going to move on to our last topic. And do we have a score that we can put up there? All right. Whoa. All right, so Team G3000 in the lead. It may be mathematically impossible for some of the teams to come from behind, but let's give it our best effort and see. So we're going to talk about low altitude level offs. Okay, this is another video we have to show you with David. But first, let's talk about this a little bit. So, question is, when the flight level change button is pressed, what speed is commanded to the autopilot or flight director? When the flight level change button is pressed, what speed is commanded? So I will collect the answers from you. Mark. Okay, all right, got that? John? Yeah, this is not applicable. Current speed, okay. Randy? Current speed. All right, 100 points for everybody. Current speed, and I think these guys get an extra 100 points. That was a spectacularly brown-nosing answer. Yeah. Well done. All right, 100 points for everybody, and an extra 100 for G3000 like they needed. 200 points. What does ALTS or the Proline ALTS capture mode signify? What does that mean to us? What's the significance of that? What does that mean? ALTS, what does that mode mean? Shall I grab some answers?
Okay. John, you go first this time. Say it again.
Altitude capture.
Altitude capture.
Okay.
This is the scoreboard.
Green.
Capture, okay. Transitioning to altitude capture. Okay.
Mark? Say that again? It's armed to capture. What if the mode is in green? What does that mean? That's the question we're asked. I feel it's written better. If it's in green. Well, their answer is technically correct. Their answer is technically correct. What does a green ALTS mode mean in the G3000? What is a green ALTS? Not what green 3000. Green, not green. Your answer was correct. What does it mean? The altitude is captured. All right, so what the ALTS mode means is that the selected altitude is being captured. So I think they all get 200 points. That was correct for everybody. So the selected altitude is
Yeah, there's some dissent.
All right, 2 more questions left, guys, on the board. 300 points. What button on the yoke will change the vertical mode's target? What button on the yoke will change the vertical mode, whatever mode that is in, the target for that vertical mode?
Okay, Randy, you guys first. Control the steering, okay.
Control wheel steering.
Mark? Control the steering.
I heard 3 control wheel steering. 300 points for everybody. Well done. And
has a speed limit, and it has a vertical and lateral definition. What is that? I need a speed, a vertical, and a lateral.
Okay, Mark, you guys first.
Okay, so I heard 4 nautical miles, 2,500, 200 knots. 4, 200, 2,500.
And vertical.
Did you say you can't hit that airspeed? Is that what you said? It's self-deprecating group. Alright, so 200 knots within 4 miles of the airport, and how I need a vertical, how high above the airport? 25, so the same as these guys said. You guys? 200, 4 miles. So all 3 of them got 500 points. Well done. All 3. So the answer is 200 indicated, 2,500, 4 miles. So what is our final score? Can we put that up?
We all know how fast things can happen in a jet. Managing your energy state and verifying the flight director modes are 2 things that can really bite you. Watch what happens if you're not focused.
Thanks, Charlie. Pilots love to talk about gotchas. Here's a couple examples of where the wrong autopilot or flight director mode used at the wrong time can pretty quickly get a pilot into trouble.
And 416 Delaware cleared for takeoff runway 24. Takeoff power set. Airspeed's on both sides. 70 knots. V1. Rotate. Positive rate.
Was that the end of the video? Alright, so we decided to talk about this because this was a forum conversation in the last year that came up about these low altitude level offs. And so we talked about this, and I think everybody got this right. When flight level change is pressed, what happens is the current, assuming you're not in VTOL, the current speed will be captured. So let's think about what that means though if you're accelerating, as you would be just after you cleaned up with takeoff thrust in, okay? So we press flight level change, the current speed is commanded, however, what's the airplane doing? The airplane's faster, so a split second later, we're now faster than that commanded speed, and maybe quite a bit more so. So what's the plane gonna do? The plane's gonna pitch up, okay? Now we may be reaching down to try to thumb that up to a faster speed, we may be reaching up here to try to select a faster speed, but while we're doing that, the plane is going to be pitching up and trying to reacquire that speed, and as a result, the rate of climb increases. So what we're going to be looking at is something like this this is I think a G3000 I chose as an example. So we start out at heading and takeoff. Then we hit filch. We were at 157, so that that's what the plane is now going to start doing. Now we ultimately want to thumb it down to 200 knots because we have the speed limit in the Class Charlie Class Charlie or Delta area. Then it's going to be active, and once we enter alt, now the plane is just trying to smoothly capture the selected altitude. It's trying to bring us from this maybe high pitch attitude down to a lower pitch attitude, and then ultimately we'll end up in the captured altitude. Well, what I think some of you have noticed, who has ever had the experience that this doesn't go very smoothly when you're trying to level off within about 1,500 feet of the ground? Anybody ever had that happen? I sure have. And I can tell you, in my experience, the ProLine autopilot tends to be the worst offender. The ProLine autopilot will tend to overshoot the altitude if you're climbing at a real high rate of climb, transitions to alts, doesn't push the nose down very aggressively, and even with the autopilot on, you might go a couple hundred feet through your selected altitude sometimes. So what would be easier? How about this? What if we cut out some steps? What if we took off in heading to takeoff mode? And what is takeoff mode? What can we call that? It's pitch, right? It's a pitch mode. And what if we just left it in takeoff mode? Look at how many modes and how many steps we could skip. So we take off in pitch mode. We leave it in pitch mode. We don't give the autopilot a chance to start pitching up to chase that filch speed we just commanded while we're accelerating. And typically, most of the planes we're flying are going to be around, 7, 8, 9 degrees. That's where the flight director is going to be when we hit the flight director on the ground, which happens to be a pretty good attitude to transition into a level off. It's not giving the autopilot a lot of work to do. And what's the other key part of this? Power management, okay? In an airplane like a CJ3, CJ3 Plus, an M2, CJ4, CJ2 Plus that has a lot of thrust, do we need full power as we're capturing our altitude? Probably not. What we can do is, with the pitch set in this range of 5 to 10 degrees that it's going to typically be when we hit takeoff from the ground, we can use thrust to keep the airspeed around 180. If our speed limit is typically going to be 200, we can give ourselves a little margin. Full thrust is not typically required once we're cleaning up. All right, these planes that I mentioned, the Mustang, maybe we could leave it a little bit longer, but the CJ3 with a partial fuel load on a cold day, it's not going to take a lot of time before that plane is exceeding 200 knots, and it's also simultaneously leveling off. And finally, what if I blow through my altitude, right? We chose this topic as one of our loss of control topics because at least one accident in the last couple of years seemed to match this profile. A very low altitude level off in conjunction with a turn in a very disorienting meteorological set of circumstances, right? And so what if we blow through our altitude? Well, one point I would leave you with is that a large thrust reduction can be your best friend to try to minimize an altitude excursion. And what I see pilots do when I'm out training is they shoot through their altitude and they push the nose over. And you have to push the nose over really far if you're climbing at a good rate of climb and you're now at 2,200 feet and you want to be at 2,000 feet. If you push the nose over in conjunction with the power reduction, you'll be surprised at how effective that can be. And just be, of course, prepared on the backside to have that thrust back in once your vertical state is settled. And I think Charlie also wanted to talk about just the importance of the attitude.
Yeah, exactly. The point about the thrust reduction is really important. The two accidents that we've seen here, still awaiting the finals, but it appears that the CJ4 in Cleveland was in full takeoff power. First level up, I think, was either 1,500 or 2,000 feet AGL, and those are flight CJ4s know that that one's capable of in excess of 4,000, 5,000, 6,000 feet a minute. So do the math, at 6,000 feet a minute, you're 15 seconds to level up. And instead, it would be much easier to bring that throttle lower back to the range up and get your flaps up and just let it come up at a very balanced, moderate 500,000 feet a minute. You're only going to 1,500, 2,000 feet. And the pitch attitude is really important on that too, which is why we recommend the pitch mode so that you don't allow the airplane to try to chase the higher pitch attitudes. So even if you need to lower the pitch, if it's a very low